All right, so this week we're going to start off by looking at conic sections. So we'll finish the ellipse and the hyperbola. Once we're done that, we're going to go to chapter 10, which is a totally different topic. That's on systems of equations. So you've probably solved systems before with elimination, substitution, so we'll review that quickly. But then in 10.2, we're going to solve systems using what's called a matrix. So it's a more efficient way of writing things down. Okay, so we'll talk about that later in the week. All right, so an ellipse. So first of all, an ellipse is a two-dimensional shape. So it's a collection of points that are in the plane. Okay? Every conic section definition starts just like that. It's a collection of points in the plane that, then they meet a certain definition. Okay? For a circle was a collection of points in the plane that were all equidistant from the same point we call the center. Okay? That was the definition of a circle. A parabola was a collection of points in the plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. So a little more complicated. This one is a little different too. It's a collection of points in the plane such that the sum of the distance to two fixed points is a constant. So you pick a point on the parabola, you measure the distance to one special fixed point, measure the distance to another special fixed point, add them up, and you will always get the same thing. Now, what that constant is, that can change for different ellipses. Okay? But for a given ellipse, the constant is the same. Okay, so what we'll do next, we'll just look at a picture. I'll show you what the two fixed points are, and then we'll look at finding the sum of the distances. Okay, so here's an ellipse. The two fixed points are B and C. Okay, point E is a point that I can drag around the perimeter of the ellipse. And as I drag it, the calculation for segment EB is going to change. And the calculation for segment EC is going to change. Okay? But when you add the two together, and you can check that one if you want, when you add them up, you're always going to get 17.30 in this particular ellipse. Okay, so let's see if we can just highlight the point. And as I drag it, that's about as short as EC is ever going to get, right about there. And then as I drag it, you can see the numbers are changing, but if you check them, they will always add up to 17.3. And this visual is pretty good because that's how you would draw an ellipse. Like if you had let's say you had like a bulletin board. Okay? If you put a push pin at point B and another push pin in at point C, and then kind of, how can I show you? Kind of take a piece of string, pull it tight around those 2 points, and then trace, running into other push pins, but just trace, keeping it pulled tight. That's how you would draw an ellipse. Okay, just 2 pins, put a loop of string around them, pull it tight, and draw it. As the 2 pins start to move towards the center and eventually become the same point, what do you think would happen to the shape of the ellipse? What do you think it would turn into? Yeah, it would turn into a circle. So the closer the two foci, that's what these are called, the two foci become, the more circular it gets. Okay? The further apart the foci, the more elliptical. And there's 2 cases for an ellipse. This is the case where the foci line up horizontal. We can also do them vertical, and that would turn our ellipse. And it's a little different than a parabola where you have 4 cases, opening up, down, left, and right. This only has 2. Right, so those 2 special points that I had in this picture, B and C, those are called the foci. Now, a parabola had a focus too, but the difference is a parabola only had 1 focus. An ellipse has 2. Okay? And we don't call them focuses, we call them foci. I'm going to show you a picture that has some of the important things in an ellipse, and then we'll kind of go through each thing. This is basically explaining the definition of an ellipse as an equation. It's actually a lot shorter to write it this way. Point P is a point on the ellipse, anywhere. F1 is the first focus. F2 is the second focus. So this equation says that the distance, that's what D stands for, from the point to the first focus, plus the distance from the point to the second focus, always adds up to a constant. Okay, and some of the other things in this diagram, we'll come back and look at them as I define them. Okay, but for now, you should know what F1, F2, P, and what's in that box. Okay, you should have all that written down. Okay, the next thing is what we call the major axis. So basically, the major axis goes right through all the important stuff. It goes through the center, it goes through the foci, and it goes through a couple other things I'll define in a second. The major axis runs through the ellipse the long way. So if your ellipse is more horizontal, like this one, your major axis is horizontal. If your ellipse is more vertical, then your major axis is also vertical. If you find the midpoint of the segment that connects the two foci, that's the center. So I didn't label that, but I should. So if you had the coordinates of F1 and F2 and you use the midpoint formula on them, you will get the coordinates for the center. And we haven't talked about it yet, but if you're wondering, well, what if I had the coordinates for V1 and V2? Could I use the midpoint formula on those two to find the center? Yep. This, I should point out too, that is a 90-degree angle between the axes. I think I'm going to mention that in a second anyway. But the line that goes through the center and perpendicular to the major axis, that's the minor axis. So in this case, the minor axis is vertical. In this case, it would be horizontal. And then one more thing we haven't described yet. It's the point where the ellipse and the major axis cross each other. I had them labeled on the diagram as V1 and V2, but those are called your vertices. So where the ellipse and the major axis cross are your vertices. Now, I want to scroll back up, and I want to look at where the vertices are in relation to the foci. I'm not sure I can make it bigger if I need to in a second. Okay. Look at where the vertices are, and look at where the foci are. How would you describe where they are in relation to each other? Comparing the position of the vertices to the position of the foci. Yeah?
They're on the same line.
Okay, they're on the same line. What else? Yeah?
They're equidistant from each other. Like V1, the distance between V1 and F1 is equidistant to F2 and V2.
Yeah, so there's a lot of symmetry here. Yep. So the distance between the vertex and the focus on the left is the same as the vertex and the focus on the right. What else? Something else about where the foci are and where the vertices are. Like they're relative to each other. Yep.
The vertices are outside
Yes, the vertices are outside of the foci. And that's how it always is for an ellipse. The vertices are on the outside of the foci. Tomorrow when we study hyperbolas, we'll see if that's the same or not. Okay? But for today, the vertices are on the outside. Okay, any questions on that? All right, so that gets most of the vocab stuff out of the way. Okay, equation of an ellipse. Okay, we always start with the equation of an ellipse where the center is at the origin. And then towards the end of the lesson, we'll go with they're not at the center. Okay, and I'll show you how to do that. Okay, so I'll give you a second to copy that down. All right, so let's go through some of the stuff here. So this is the case where the center is at the origin. You'll know when you have an equation where the center is not at the origin because the numerator is going to be a little bit more complicated. Denominator looks the same. Everything else looks the same, but the numerator is a little bit more to it. C is going to be a variable that we use with an ellipse, and C is going to represent the distance between the center and the foci. So in this particular case, the center is at the origin. One of the foci is C units left of the origin, so negative C0, and the other one is C units right. So notice in this case, things are left and right, okay? Left and right, not up and down. The major axis is left and right. Okay? The major axis is the important axis that everything is going to go through. The vertices are going to be A units away from the center. A units to the left, A units to the right. So what I like to do is just kind of generalize those two things and write them down. So C is the distance from center to focus. B I haven't really talked about. I'll mention what B is in a second, but A and C are kind of the important two. A is the distance from center to the vertices. And B, in this case, is the distance from the center to the minor axis. Okay, so if you're wondering, well, what do I mean by distance from center to minor axis? Go back to the picture. This is B right here. That's the distance from the center to the minor axis. Center to focus, center to vertex. I just drew them on different sides so you could kind of see them. Okay, a couple other things. In an ellipse, A is always bigger than B, and B is always greater than 0. So that means A and B are always positive, never negative. Okay, and kind of the trick, we haven't gotten to this yet, but how you can tell if an ellipse goes the long way or the tall way is you look where A is. Look where the bigger number is. If the bigger number is under X, the ellipse is going to go in the X direction. If you put the bigger number under Y, it's going to make the ellipse go in the Y direction. Okay. And another formula they give you is this relationship between A, B, and C. Okay. What's usually going to happen in a problem is you're going to know 2 of these. They're not going to give you the third one, but you can use this equation to find it. C squared equals A squared minus B squared. Okay. It's kind of important to make sure you copy everything correctly for an ellipse, because when you do hyperbolas tomorrow, everything is almost exactly the same, except you change one thing in this equation to make it a hyperbola. You just change this plus to a minus. That's it. All right. So it's kind of good in the fact you don't have a different formula to remember, but it's so similar, it's very easy to confuse it. Don't worry about the intercepts. We're not going to really focus on that too much. These three things I already gave you. A is the distance from the center to the vertex. B is the distance from the center to the minor axis. And C is the distance from the center to the foci. Okay, so they're right on the side of the board if you need them. Okay, so the kinds of problems that you could have here is I tell you a bunch of characteristics about the ellipse, you tell me the equation, or we can do it the other way around. I'll give you the equation, you tell me all the characteristics. All right, so this is the case where the center is 0, 0, the focus is 3, 0, the vertex is negative 4, 0. Anytime you do a conic section problem today or tomorrow, you always want to start by finding A, B, and C. Okay, so looking at the information they gave us, does anyone think they could tell me what, let's start with A, if we have enough information. Okay, do we have enough information to find A? Abby? Yeah. What's A in this case?
4.
4. The distance from the center to the vertex. Okay. What other letter do we have enough information to find directly without really doing any calculations? Yep.
C.
C. Distance from center to focus, which is how much? 3. Now, to write the equation has B in it. But I have A and C, so I can solve for B. Okay, so we'll use our formula C squared equals A squared minus B squared. So C squared equals A squared minus B squared. Bring the 16 to the other side. Negative 7 equals negative B squared. So that means 7 is B squared. Now, technically, you don't need B. Okay? The formula asks for B squared, and we have it. But if you were graphing it, you would want to know B, because that would tell you how far to go on the short way. Okay? So what would B come out to if they asked for it? Yeah?
Square root of 7.
It would be the square root of 7. So if I was graphing this, okay, just kind of a really quick sketch, not to scale, I would be going left and right 4 units. Negative 4, positive 4. That's the distance from the center to the vertices. I would be going up and down square root of 7 units. So it's not symmetric, but that would be square root of 7, and that would be square root of 7. This section and that section. And that would give me, once you have those 4 points, you can make a decent sketch. Okay? Any question on that idea to sketch it? Now the foci, C is not really part of the sketch at all. The foci are inside the ellipse. Okay? They would be like 3 units over and 3 units over. Okay. They're inside. All right, so let's write our equation. First of all, every equation for an ellipse starts out like that. It's always a plus, and it's always equal to 1. Okay, next step. Let's go back and look at it. X squared is always first. Y squared is always second. So actually, you can even go like this. Every ellipse at the center is going to start like that. Now, eventually, you're going to have to decide, does a squared go under the first denominator and b squared under the second, or should you switch them? Well, the trick is, whatever direction the major axis goes, that's where you put the bigger number. So to figure out the direction of the major axis, graph these points. I already graphed them. 1, 2, 3, 4. they all line up horizontal, which means the major axis in this case is the x. So we're going to put the bigger number under x. And what's the bigger number? It's always a. A is always bigger than b. So take the bigger number, square it, put that under x. Take the smaller number, square it, put that under y. And that's your ellipse. Any questions on that? Now, is that something you could type in on the graphing calculator the way I have it written? No? What would you have to do, Caleb, to type that in?
You'd have to make it like a y equals.
Yeah, you'd have to make it y equals, which isn't awful. You'd have to subtract this x squared over 16 to the other side, and then multiply by 7, and then take a square root. And the way your calculator would graph it is it would do top part, bottom part separate. Okay. That's how it would look. I'm not too concerned about graphing it on the calculator, but that's how you would do it. Okay. Any questions on that equation? All right. So let's try this one. Okay. This time, I'm giving you the equation, and I want you to tell me all the important things about it. There's generally 4 things you need to tell me: the vertices, foci, center, direction of the major axis. Okay, but to do all that, we're going to start by finding A, B, and C, okay, just like last time. Okay, so Dylan, what's A in this case?
5.
5. A squared is always the bigger number. Take the square root of it, and there's A. Leo, what's B?
9. Or
3, right? B squared is 9, so B is 3. Now, the only reason I need C is because I'm going to ask you what the foci are. So we have to find C. Trevor, what's the formula to find C?
C squared equals A squared minus B squared.
So C squared equals A squared minus B squared. So C squared is 16. And Tessa, what does C come up to? 4. Okay. So now we have everything we need. Okay. Let's start by describing the, let's do the vertices. Okay, so vertices. They are A units away from the center. So I know the vertices are 5 units away from the center, which, you know what, actually let's write that down first. Center. Sam, what's the center here?
0, 0.
Yeah, yep, it's going to be 0, 0. Okay. So now I know the vertices are 5 units away from the center. But the question is, are they 5 units up and down, or 5 units left and right?
Yep, left and right.
It's left and right. The bigger number is under x. That means everything goes in the x direction. All right, so 5 units to the left of the center would be 5, 0. 5 units, I'm sorry, that's 5 units left of the center. 5 units right of the center, 5, 0. If you wanted, I guess you could put this plus or minus 5, 0. Same thing. All right, so we've got the vertices, the center, foci. Rebecca, what are going to be the equation? What's going to be the coordinates for my foci? Yep. And negative 4, 0. Okay. So 4 units left, 4 units right. And the major axis, we already said this, is horizontal. So I guess the first 2 things you should really figure out is find the center, then find the major axis. what you do after that doesn't really matter. Okay. Any questions on how we found those four? Yeah.
How did you find the axis?
So if you look at where the bigger number is, if the bigger number is under x, then the major axis goes in the x direction. So when we get to something like, I'll show you in a second, this, which I'll put back on the board shortly, if a is always the bigger number, if the bigger number is under y, now it's up and down. Okay? And everything will be above, below the center. Okay? All right, actually, that's where we're at right now. So here's the other equation. This is still the case where the center's at the origin. And all the facts I told you about A, B, and C are the same. The foci are C units from the center. The vertices are A units from the center. But the difference is, remember the vertices and foci are along the major axis. Now the major axis is vertical. Okay, it goes up and down. So the only difference in the equation is A and B have switched places. So this is important for an ellipse. X and Y never change places. Okay? At least with all the problems I give you and what you see in the homework, X and Y will never switch. X first, Y second, always. It's the A and the B that can switch places today. Okay, we got to keep that straight for tomorrow. Same inequality. A is always bigger than B, which is bigger than 0. And same equation that relates A, B, and C. Now, if you look, even in the packet I gave you, or maybe online, you might not see this equation written this way. You might see something like this. Is that equation that I just put here different than the other one that has an arrow pointing to it? No. They just move something to the other side. Right? So there's tons of different ways you can rearrange it. But that's generally how I write it. C squared equals A squared minus B squared. Okay. Any questions on that equation? All right, so let's look at an example here. Okay, so this is a discuss. 9x squared plus y squared equals 9. What's wrong here? If this is kind of what we call the standard form of an ellipse, that is not in standard form. Yep.
It doesn't equal 1.
It doesn't equal 1. So before we can do anything, we should get it equal to 1. What would I have to do to make the right-hand side equal 1? Okay. Divide everything by 9. Yep. Okay. 9 divided by 9 cancels. So really all I'm left with is a 1, but I would put it just so we remember what's there. It's y squared over 9 equals 1. All right, now we're ready to discuss it. Let's start with the two things I said to start with last time. Let's find the center and then the major axis direction. Okay, Tanya, where's my center here?
0,
0, 0. Okay, just to show you a case when it's not 0, 0, we'll get to this eventually. But when it's not 0, 0, everything's going to look the same except the numerator. The numerator is going to have like x minus a number and y minus a number. Or it could be y plus a number if you subtract a number. Okay? So you'll know when the center has been shifted. All right. So the center is 0, 0. Which way does the major axis go here? Horizontal or vertical? Yep.
Vertical.
Vertical, how do you know?
because the bigger number is under the y squared.
Right, the bigger number is under the y. Now, in order to figure out the vertices and the foci, we really should be writing down A, B, and C at this point. We don't need them up to right now. Okay, but J.N. said the bigger number is under y. We know the bigger number is always A squared. So in this case, A is 3. What about B? What's B? Yep. B is the square root of 1, which is 1. And C, C squared equals A squared minus B squared. So C is the square root of 8. Okay, so we've got the center, major axis, vertices. How about, Shauna, what is going to be the coordinates of my two vertices?
-3, 0, and 3, 0.
I agree that we should be using the 3 to find the vertices. So that's the right number.
Okay, 0, -a, and then 0.
Right, we want everything to be up and down this time. So we're going to go above and below the center. So 0 plus or minus 3. And Dylan, my foci?
0 to -8, and then 0 to negative square root of 8.
Yep.
And then 0 to positive square root of 8.
And positive. Yep. Now, if you were actually graphing the foci, you'd probably want the decimal for square root of 8. But to just write it down, that's fine. Questions on how we got that? All right. Let's try one the other way this time. Here's the focus. Well, actually, they're only giving us one focus. Well, we know an ellipse has to have 2. So not that the question is asking it, but if you had a focus at 0, 2, where do you have another focus? Yep. 0, -2. Do you need to know that for this problem? No, not really. But you should know that. Okay, so let's find the equation. Now, you can't just assume the center is the origin. But they've given you enough information that you can prove the center is the origin. How come? Yep.
Because the vertices are at -3, 3, so the middle of that would be 0, 0.
Yeah, exactly. The vertices are at +3 and -3. And if you find what's exactly halfway between, that's the center. Halfway between the vertices or halfway between the foci. Same thing. So the center is 0, 0. So I can kind of write that as an extra piece of information that I wasn't given. Now I think we can find A and C. Okay. What would A be, Gracie, in this case? Distance from center to vertex? 3? Yep, I agree with that. And Sam, how about C? 2. All right. And Sam, what's the equation for finding the B? It starts out C squared. A squared minus B squared. So we get 4 equals 9 minus B squared. So 5 is B squared. Really, to write the equation, you need B squared. But if you want B for graphing purposes, it would be the square root of 5. Okay, so let's start off with our template, and let's fill in what we can. Is there anything there that I can fill in that stays the same for every single ellipse that we do? Doesn't even matter what numbers are up above.
X squared and Y squared.
X squared is always first, Y squared is always second. Yep, and it's always equal to 1. Now, we have to decide where to put A squared and B squared. Where is A squared going to go? Under which letter? Yep.
Y.
Yes, how come?
Because the major axis is the y-axis.
Exactly. We want the bigger number, which is a, to go under the y, and that'll make this go vertical. So a squared is 9, and b squared is 5. Okay. And there's your equation. Any questions on that one? All right. So before we get to shifting the center, we'll talk about a circle, which is really just a special case of an ellipse. A circle is where the two foci kind of merge into one. Okay. So what would happen in the case of a circle, is if you think of this, let's pretend, again, it doesn't really matter and you don't really call it this in a circle, but let's pretend that's your major axis. And that's your minor axis. Well, the distance from the center to the vertex and the distance from the center to the minor axis, how would they compare in this case? If you measure them, yeah. They're the same. If you call this the center to the major axis, whatever that is the same as the center to the minor axis. So what ends up happening is the a and the b, two denominators, are the same. So you could just use the same letter twice. A squared, or b squared, it doesn't matter. And what they usually do when they write the equation of a circle is, since these two letters are the same, it's very easy to move that one letter to the other side and then have an equation without fractions. So what would you have to do to move this a squared to the other side? Yeah.
Multiply by a squared.
Yeah, so what they usually do is they multiply everything by a squared. And then you get that. X squared plus y squared equals a squared. Now, they actually don't even use the letter a. They normally use a different letter. Because does anybody know what the a is going to represent here? If you look back at this diagram, a isn't really the distance from the center to the vertex because circles don't have vertices.
Maybe the radius.
It's the radius. So you normally see the equation of a circle written x squared plus y squared equals r squared. Okay? So that's why it's just a special case of an ellipse. And that's all I'm really going to say about circles. Any questions on that? All right, so last thing is when the center is shifted. Okay, so what we're going to use for our variables to represent shifting the center is h comma k. So h comma k is the coordinates of the center. H will do your shifting left and right. That's why we always put the h grouped with the x, because x is left and right. K will do your shifting up and down. That's why we always group the k with the y, because y is up and down. Other than that, everything else is the same. We still have a squared and b squared in the denominator. Depending on which way you want your major axis to go, you can switch them. Still equal to 1. Inequality still holds true. A is always bigger than b, which is bigger than 0. And same formula that relates a, b, and c. C squared equals a squared minus b squared. In the packet that I gave you, these formulas are on page 394. So if you're going to make a reference sheet for the test, these are probably the formulas you want to put on it. Because if the vertex is at the origin, then just pretend that h and the k are both 0. You can just cross them out. Okay, and if you cross them out, now you're right back to the formulas we started with. Okay, so any questions on those? right, so we'll try a couple examples. You can do these the same way. Either I give you the equation and you tell me all about the ellipse, or I'll tell you some stuff about the ellipse and give me the equation. Okay. Does everybody have the two equations?
No.
Okay, so this kind of problem starts off the same, except you have two extra letters to find. You want to find A, B, C, but now you have to find H and K. Anyone think they can tell me any one of those 5 letters relatively quickly without any calculations? Yep.
H is 2 and K is -3.
Yes. H is 2, K is -3. Now, if you notice here, look at all the y values. They're all the same. So, what does that mean? If you were to draw these 3 points out, how would they line up? We've got one that's right 2 down 3, right 3 down 3, right 5 down 3. They would all line up.
In a horizontal line.
They're all going to line up in a horizontal line at -3. Okay? So that means when you want to find the distance between them, don't worry about the y values. Those are all the same. Just look at the difference between the x's, because they're all going to be lined up horizontal. Okay? So based on that, anyone think they can tell me what A is? Yeah.
3.
Yeah, distance between the center and the vertex is 3. And how about B or C? Which one can I find directly without using any equation? Leo?
C is 1.
Yep, we can find C, distance between the center and focus, 1. And now use your equation to find B. C squared equals A squared minus B squared. So B squared is 8. And really that's what you need for the equation. For graphing purposes, you could find B as the square root of 8. All right, so now let's write down what we can. We've got x minus something squared plus, and that minus might change to a plus. I don't know if I subtract a negative. I'll look at that in a second. Y minus k squared. And equation is always equal to what number? 1. Okay. Oops. I cannot write and talk at the same time. All right, so let's take a look. X minus h. H is 2. Y minus k. K is -3. So what's going to happen there? Yep.
Y plus 3.
Y plus 3. And that's where you have to be careful. If I give you the equation and ask you to work backwards, some people say, oh, the center is 2, 3. No, it's 2, -3. So it's the number after the minus sign. All right. Jayan told us everything lines up horizontal. So we want the bigger number under which letter? X or Y?
It'd be X.
We want the bigger number under X. So we're looking at these two. A squared is 9. B squared is 8. And that's your equation. So not too much harder when you shift it. You just have to find the H and K. But they gave it to us. Yeah.
Can you just explain how you figured out if it was vertical or horizontal?
So if you graph all these points, you've got one that's right 2 down 3, right 3 down 3, right 5 down 3.
Oh, okay.
They're all down 3. So they're basically going to line up like that.
Okay.
Okay. You can just look at the letter, the number that's the same, and that'll tell you the direction it goes. If you get confused, just use a little piece of graph paper, sketch out the 3 points, and see where you're at. Right, any other questions on that? All right. So this will be our last one. All right, so we want to discuss this one. This is a problem. This isn't written anywhere close to standard form. So what did we have to do with a parabola when it wasn't in standard form? We only had to do this once because there was only one variable that was squared. Here we have to do it twice because there's 2 variables that are squared.
Complete the square.
We have to complete the square. So what we want to do is set it up so our x's are together, leave a little room. The y's are together, leave a little more room. And we're going to put constants on the other side. So we've got 4x squared. Actually, that 4 is a little bit of a problem too. We have to deal with that. But the y squared is better. That's ready to go. So we got 4x squared minus 8x plus y squared plus 4y equals -4. So I said y squared is ready to complete, but how come the x squared isn't? What's wrong here I have to fix? Yep.
There's a coefficient.
There's a coefficient, and the only coefficient you're supposed to have is a what? A 1. So let's factor it out. Now, leave a little bit of space because this is where we're going to complete the square. We'll do it for the x's. And then we're going to do it for the y's. Now, I didn't have to factor anything out on the y's at all. Okay, so let's start with the x's. We focus on the -2. And does anyone remember the 2 things you have to do with that? Yep.
Divided by half.
Yep. So take,
Square.
well, careful, not divide by 1/2, but because if you divide by 1/2, that's going to double it. Is that what you want to do? Divide by 2, or you could say multiply by 1/2. I knew what you meant. But all right, so divide it by 2, we get -1, and then what? Squared. So -1 squared is +1. Okay, so keep that there for a second, but we have to remember what we really just did. Let's do the same thing here. What's half of 4? 2, square it. 4. So, in total, how much did we just add to the left? Yeah? 8. We added 4 here, and we added 4 there. So we added 8 on the left. We got to make sure we add 8 on the right. That's the hardest part. All right. So now we have 4. This is going to factor as x minus 1 squared plus, how did the y's factor? Y plus 2. So now we're getting there. We can start to see our center. It has something to do with a 1 and a 2, but maybe we should have a negative in there. Equals -4 plus 8 gives me 4. Now, one more thing to get this in standard form. It's supposed to equal what number?
1.
1. So how can I do that?
Divide by 4.
Divide by 4, and then we're good. 4, 4, 4. Okay, so those are gone. We get x minus 1 squared over 4 plus y plus 2 squared over 4 equals 1. And now this problem is basically just like the last answer that we had. That never happened. Is that what you were going to say? Thank you. Okay. Questions on that? All right, so that's just how to complete the square. We already know how to do that. Take half, so we don't have to write that down. Okay, let's go through. What's A in this case? Yeah, Juliana?
Would be 2.
A is 2. B is 1. And C is going to be 4 minus 1 or the square root of 3. A squared minus B squared, and then take the square root. Okay, be a little careful with H and K. What's H in this case? Yep.
1.
Yep, I agree. H is 1. What about K? Gracie? -2. Now we've got all the information we need to discuss it. Center is HK. The major axis. Let's see what the bigger number is under. Bigger number is under Y. Major axis is vertical. Okay, let's do the vertices. The vertices are 2 units above and below the center. So what would be the coordinates that is 2 units below the center? Mm-hmm. 1, -4. 2 units above the center? 1, 0. Now the foci, because it's a square root, it's going to be kind of a messy coordinate, but there's not much we can do. The foci are going to be square root of 3 units above and below the center. So what I would do is just write it this way. -2 plus square root of 3 units will give you above, minus square root of 3 units will give you below. Okay, so not too bad to figure out once you complete the square. But until you complete the square, you can't look at the original and tell anything really. Okay? Okay, so that's ellipses. So tomorrow we'll finish conic sections with hyperbolas, and then we'll be done with the packing. Okay, so homework tonight, remember this is in the packet. 13 to 17. Let me just double check if that's, I think that's matching, so yeah, that's all. 21. 27 to 31, just odds. 39 to 41. And actually, you know what? I could kind of shorten this because it's 39, 41, 43, 45, 47. So it's just 39 to 47 odd. Just an easier way to say it. And 55. Okay, we'll take a look at that tomorrow. Don't forget my extra help day this week is back to Thursday if you need to stay to make anything up.